Welcome back to another explainer. I am absolutely thrilled to have you here today because, well, we're going to unlock some major insider secrets. If you're tackling the Cambridge 9709 mathematics syllabus, you already know that hitting those top marks, it requires way more than just knowing your numbers. It requires knowing exactly what the person grading your paper is actually looking for. So today, we are prying open the examiner's playbook, and we're going to completely demystify one of the absolute trickiest topics on the board, algebra and partial fractions. Whether we're talking about linear factors, repeated factors, or those tricky quadratic factors, we're going to look strictly at the hard data from Cambridge Principal Examiner reports. We want to see exactly how you can secure literally every possible mark. Let's get into it.
Look at this quote straight from the source. It says, "Algebra, partial fractions, is one of the most misunderstood areas in mathematics." I mean, just think about that for a second. Even top-tier students routinely trip up here. And it's not necessarily because the math is impossible, it's because the structure of what examiners actually expect is completely misunderstood. But hey, don't worry, because by the end of this explainer, we are going to fix that misunderstanding once and for all. I'm going to show you exactly how to align your brain with their grading rubric.
Okay, let's dive right into our roadmap for today. We are breaking this down into 4 highly structured pillars: core principles, the procedural framework, critical analysis, and finally, the top 3 examiner warnings.
Starting off with Section 1, Core Principles. This is all about establishing your conceptual framework before you even touch an equation.
Before we start trying to pull apart a repeated quadratic factor, we really have to understand the theoretical architecture of Cambridge mathematics. Listen, mastery does not equal memorization. It just doesn't. According to the syllabus, top-performing students exhibit a connected conceptual understanding. So what does that actually mean for us? It means they have a transferable understanding that is fully capable of handling completely unfamiliar contexts. Imagine you open that exam paper and you see a complex fraction. It's got a hidden quadratic factor in the denominator that doesn't perfectly match the textbook examples you've done 100 times. In that moment, your conceptual understanding of algebraic division is what saves you, not your rote memory.
Cambridge's theoretical architecture rests on 3 main pillars: precise definitions, causal relationships, and integration with other syllabus areas. And here is a huge tip. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections achieve significantly higher marks. It is all about showing the examiner that you see the whole mathematical landscape, right? Not just a single isolated algebra problem sitting on a page. Moving on to Section 2, the procedural framework. This is where we activate what I call the method mark strategy.
So, Cambridge actively rewards the systematic process of your math over simply landing on the final product. Getting the right answer is great, but the journey matters more. This builds a standardized sequence for tackling literally any partial fraction problem. Step 1, identify the key elements. Are you dealing with a standard linear factor or a repeated factor, like, say, x minus a squared? Step 2, apply the relevant analytical principles to set up your algebraic identity properly. Step 3, execute your analysis with completely clear working. That means whether you're substituting values or equating coefficients, the examiner needs to see it. Step 4, verify those results. And Step 5, present it in the appropriate format. I highly recommend taking the first letters of these steps, I, A, E, V, P, and creating your own mnemonic memory hack right now. Just invent a funny phrase. That little memory trick will keep you totally grounded when exam panic tries to set in.
Now, if you don't follow that structured sequence, you end up with what examiners call superficial breadth, and that's a trap. The academic benchmark for the 9709 syllabus actively prioritizes analytical depth over that superficial breadth. They absolutely do not want you to just scatter a bunch of equations on the page and cross your fingers, hoping one of them is right. No way. They require deep, logical, structured reasoning that proves you understand exactly why you are making every single algebraic move.
Which brings us to Section 3, Critical Analysis. Let's establish your problem-solving rhythm. Now, what's really interesting about this slide is the stark contrast between a generic student approach and the Cambridge expected standard. It is a classic examiner alert. While generic answers just ignore variables and merely list facts, Cambridge expects your answers to be highly specific to the context. They want you to identify limitations and assumptions. Instead of just listing numbers, they want to see comparative analysis, identifying similarities and differences, and backing it up with evidence. Basically, if your mathematical logic could apply to any generic algebra problem without acknowledging the specific constraints of the fraction you're actually deconstructing, well, you are losing marks.
To hit those high expectations, you need to adopt a strict deconstruct, solve, evaluate rhythm. First, you deconstruct. You identify the given information and break the algebraic fraction down into logical steps.
Then you solve systematically. Finally, and guys, this is the part most students totally skip, you evaluate by checking for reasonableness. Here's a pro tip. Can you substitute a random value for x back into both sides of your final identity to confirm they actually match? This rhythm forces you to confront the assumptions you've made, consider your algebraic substitutions, and fully grasp how those elements affect your final conclusions. It is literally the ultimate safeguard against careless errors.
Finally, Section 4, Examiner Warnings. Let's look at the top 3 mistakes students make.
There are exactly 3 major traps when it comes to dealing with linear, repeated, and quadratic partial fractions. I really want you to burn this number into your mind, because avoiding these 3 specific mistakes, it's often the difference between just getting a good grade and delivering a perfect paper.
Okay, warning number 1, confusing cause and effect within your algebraic manipulation. This specifically happens when you're choosing between equating coefficients versus substituting values for x. You have to make sure your logical flow actually makes mathematical sense and doesn't contradict itself mid-calculation. Warning number 2, forgetting to check your format and presentation. Seriously, if you drop the identity symbol, those 3 horizontal lines, or if you fail to show your substitution clearly, your billions just won't count. The examiner can't reward what they can't clearly follow. And warning number 3, setting up the wrong numerator. Automatically putting a constant c over a quadratic factor instead of cx plus d shows a complete lack of context for the specific variables you are dealing with. Always ensure your setup matches the degree of the denominator.
So, I want to leave you with this final provocative thought. When you sit down to study tonight, will you fall into the generic trap, or will you apply the method mark strategy to your next past paper? Remember, knowledge is only power if you actually apply it. Grab a past paper, test out that deconstruct, solve, evaluate rhythm we talked about, and just watch your method marks soar. Thank you so much for joining me for this masterclass explainer. Make sure to subscribe so you never miss our next deep dive, and I will see you next time.